Okay, we're at the tail end of Module 1, and we're going to kind of close it out by looking at applications for systems of equations. In Lesson 22 and Lesson 23, we learned how to solve systems of equations by either using substitution or elimination. So when we talk about systems, we have the available methods of substituting a value in to one variable and solving for one equation with one variable, or we can eliminate one variable. So we're going to use one of those two in our problems today, lesson 24 and 25, applications to systems of equations. Okay, so that's what we're going to be doing here today. So here in lesson 24, and we're going to combine the two, in the opening exercise that your book provides for you, you're going to be tasked with reading a context problem and then, first of all, establishing what the two equations are. So here the answer is provided for you with the exception of solving the system. And so we're going to kind of go over a couple of examples, and then we're going to set up some other examples and actually do the solving of the systems and the equations in class. Let's start with the opening exercise. So in this opening exercise, we need to be able to really read and understand, look for keywords like sum, the sum of your weight, and twice mine is 361. That alone allows for us to come up with an equation, x plus 2y is equal to 361, because we have to establish that we're putting x equal to the number of pounds, Tweedledee as it says here in the answer, and then the other person, y, is the number of pounds, and they call him Tweedledum. And then they're just using the word sum to represent addition. Twice, there's that 2 times y, and then 361. And then you'll notice that in the opening exercise of your book, it goes on to read the sum of your weight and twice mine is 362. So in the second equation, you'll notice that y plus 2x. Really look at that and wonder, or at least think about, why did they switch those? Regardless, they have two equations, two unknowns, and then they get the answer of the Tweedledum weighs 120 and the Tweedledee weighs 121. Let's see why. So I'm actually going to show you by using systems, substitution or elimination, how they came up with this answer. So let's look. And so one of the first things I notice is I'm going to go ahead and solve for x in the top equation. And I get x is equal to a negative 2y plus 361. And so by moving the 2y over, I can get what x is equal to, and then I'm going to use this equation, and I'm going to plug in for x. In this case, x is this negative 2y plus 361. Is equal to 362. And so I go ahead and solve. And I'm going to combine here and get negative 3y. Slow this video down if you have to. Divide by a negative 3. And I get y is equal to 120. And that matches our answer of 120 here. When I substitute this back into y, then of course I would most likely get, and I will get my 121 pounds as it says there in the answer. So we're using systems to solve, but we have to set the system up first. And so there's our first example. So in this example, I want you to pay particularly close attention. We're not going to solve, we're not going to show you the solution. We get 6 and 14. We get this, but pay particularly close attention to how did they get that from this? And how do they get this equation from that? And so you'll notice they're taking D and Q. D is the number of dimes, Q is the number of quarters. And you should be wondering, well, okay, how did they get those two equations? And that's part of this lesson, being able to read context of a problem and then convert to two separate equations. From there, it's just using elimination or substitution to solve. Let's look at setting up a couple others. Okay, so let's look at number one. We're going to try this from the beginning with no help from the book. Find two numbers such that the sum of the first and 3 times the second is 5, and the sum of the second and 2 times the first is 8. First of all, we have to declare our variables. And so I'm going to declare that if we have two numbers, X and Y are my two numbers. I'm going to say that X will be my first and Y will be my second. From this point, I can then go and I can begin to read carefully. The sum of the first and 3 times the second. And that means the first, X, plus 3 times the second is equal to 5. So that's how we want to dissect this sentence into an equation. And then the second part. And then the sum of the second and then 2 times the first is 8. So we just read from left to right. Sum, the second, which was right here, the second. So again, the sum of the second, Y, and 2 times the first. 2 times the first is 8. So there's our system. And from there, we would solve using either substitution or elimination. Okay? All right. So we're going to look at one more, and then we're going to come back to class, and we'll solve these two that I just set up, and then we'll look for some others as practice. Sometimes we're setting it up and it's not going to be a system. For instance, in lesson 25 here, the first problem as we go over lesson 25, it's just reading it and noticing, hey, this is not going to be a system of equations. And so let's look at number one, solving the first problem or the following problem first by using the tape diagram. We are not going to use the tape diagram. We are not using the tape diagram. We're instead going to use algebra and just setting up one equation. In a school choir, half of the members were girls. That meant half the other members were boys. At the end of the year, 3 boys left the choir, and the ratio of boys to girls became 3 to 4. How many boys remained in the choir? Well, because it was half and half, I'm going to go ahead and just pick a variable. Let's just say X was equal to boys and X was equal to girls. It's the same variable because it was half and half. It doesn't matter. Now, the next part of the sentence, at the end of the year, this is where you begin to watch. 3 boys left the choir, and then the ratio of the boys to girls became 3 to 4. So X, meaning this X right here, the boys, 3 boys left at the end of the year. And then this X, the girls, well, the ratio of boys to girls at the end of the year end up being 3 to 4. And so this proportion this proportion, top being the boys, bottom being the girls, is really a matter of just cross multiplying and solving for x. Cross multiplying, and you get 4 times x minus 3 is equal to 3x. Distribute through, subtract 4x on both sides, and then x, the opposite, is going to be 12. And so the number of boys was 12 at the original, and the number of girls is 12 as well. And that concludes that problem. 24, more about converting to system of equations. And 25, sometimes it's just converting to an equation. So that's where we're going to stop this video. And again, we'll be in class after the video to work out the solution to that first system we set up, and then we'll practice the rest of the day. All right, good job.